Hello everyone. Can someone ping in the chat whether the screen and my voice is visible? Screen is, my voice is audible and the screen is visible. Would be good to get started. If someone can just chat whether my voice is visible or not. Hi Kesavan, can you do it? Okay, since I don't get any response, I assume my voice is audible. Uh, okay, thank you, Kesavan. Fine. So let me get started without wasting any time. Thank you for taking your time to participate in this session. I'm going to talk about how analytics is being done in the IoT world and going to present an end-to-end demo from the data capturing till visualizing it, both in the Azure Databricks and Power BI as well. So this is going to be my the quick talk about the title. And this is Dinesh Kumar, and I'm a product manager at Kissflow for the analytics part. And I have experience around 9+ years around data and cloud, and been part and played different roles from being an engineer till being a product manager. That is based upon big data, business intelligence, and low-code based products. And apart from my confines of work, I also get actively get involved in tech communities and share my knowledge as well. So with that, my talk would not be about the types of algorithm types or machine learning models, kind of thing. More time, I'll be talking about how IoT analytics is happening in the industry level and what skill sets are expected if you are wishing to switch to analytics or in specific to IoT analytics. And to the whole, I'll be taking a couple of industries, that is energy and healthcare industries, as base for the examples and the use cases that I'm going to walk through. So tools we use to get things done are generating lot more data than ever, but this data is often noisy, inconsistent, and highly variable as well. This makes it hard or even impossible for businesses to gain value from it. This is where IoT analytics comes in, right? So the basic operations will be happening from the data ingestion, that is the IoT devices emitting the data, and there will be a strong pipeline, real-time pipeline that could accept the inflow of data, and it will be stored somewhere, and the data preparation happens. If it is a machine learning kind of workflow, then the training, the ML model training happens, or if not, after the preparation, the data will be visualized, analyzed, and respective action items will be taken. In a very short purpose, there will be three main actions happening in IoT analytics. That is the collection of data, analyzing those collected data, and reacting based on the results produced from the analysis, right? And mostly who will be benefiting out of this, right? This is going to benefit two main people in terms of in terms of business terms of in business point of view. One is the enterprise users, and the other persons is device manufacturers. Enterprise users are the one who use that particular device for some business purpose, right? For example, they might be having an IoT device to detect the temperature of the warehouse, so that uh, they, the wastage of goods doesn't happen because of any AC failure or any temperature outage or something. So they are the business users who actually use the devices, and device manufacturers are nothing but uh, those IoT device who are manufacturing, right? And of course the machinery people as well. So when they're getting a lot of telemetry data, obviously the device manufacturers will be able to maximize the utility and also minimize the downtime of that particular machine as well. So these are the main things uh, where you get the operational insights out of doing IoT analytics. So these are the three basic areas which happens before starting the analysis itself. Of course, this takes a lot of time as well. This is the actually takes a lot of time and ensures that the produced insights are valuable because the quality of data that has been captured and stored, right? So what happens is via some MQTT topic filters or any Kafka streams or whatever it may be, via those pipelines, the data will be captured and it will be sent through pipelines for the ETL purpose, and it will be stored into some data store, right? So data stores, you can mean it in two ways. Either it could be in a table format, or even it can be a raw files as well. Raw files in the sense cleaned files. That's what I mean. From that, three different users will be playing over this data stores. One, a BI people will be directly calling the data store and they'll be visualizing. For example, let's consider that in Azure Databricks, we have cleaned data. A Power BI user might connect with Azure Databricks and he might visualize the data directly. And there will be different users like data analysts who play with SQL query very well. So they'll be connecting with this data source, the same Azure Databricks, and write SQL queries on their own and produce some insights by themselves. And there will be different set of people who who are nothing but let's consider machine learning engineers, that is data scientist people. So they'll use this historical data uh, within their Python notebooks, and they'll be creating models, or they'll be using this historical data to train their machine learning models. And those machine learning models will be used by this dashboard or some other business purposes to predict the future outcome. So these are the three people. First one is BA engineer, considered like that, and the second person would be data analyst, and the third person would be data scientist. So what happens when it comes to when it comes after we have a clean data? There are two main purposes getting solved. One is monitoring and the analytics, right? Even before cleaning the data itself, monitoring would happen. Let me explain that while we walk through some of the examples as well. So I have just listed few use cases by department, but for the time purpose, you can even check it back later in the same YouTube video, just scrolling up to this particular slide, because if I start to explain each and everything, it will go on a lot. So for now, let me explain two simple things. Usually weather stations, there will be IoT devices to monitor the air quality. Then and there, it will be capturing the air quality in a regular interval time. Let's take 30 minutes or 15 minutes or so. And based on historical data, it will be predicting the pollution levels that would arise in a week or so, or maybe in an year as well. That's based on that prediction result, the government will be taking the necessary actions. That would be one simple use case. And let's take another example in case of agriculture, where you'll be having devices that has been fixed in the soil that would be capturing the dampness. ஈரப்பதம்னு சொல்லுவாங்க தமிழ்ல. The dampness will be capturing, and it will be monitoring the dampness level is okay or not, and all eventually it will be increasing the crop yield, right? It will not decrease the quality of crop that is being growing, and also it also helps to use water effectively. Only when it is needed and what amount of time the water will be emitted. So the water will be saved a lot as well. So when it's being used in smart farming. So and by the way, let me just tell a quick example of monitoring purpose, right? So as I told earlier, there will be the data will be captured from the IoT device, and scenario by scenario it would differ. Once it is being captured itself in real time itself, it might be showing the data in the dashboard, because very sensitive informations or very time considering informations, like let's take an example of oil rig uh, oil rig that digs hole and sucks up the oil in Saudi Arabia or some oil field, right? So constantly the temperature of the rig will be monitored, because it will be operating so heavily, that to digging into that rock or sand kind of thing. So if it is crossing, if it is getting so too much of heat, then the device would get fault, right? So a constant and real-time monitoring would be needed, where the temperature would be monitored then and there, and in case of any anomaly, immediately the respective action gets happen. Either it would be alerted to the user, so and so temperature is getting raised, take care of that, or it might even take action by itself by turning off the rig automatically. So both the things is very common. So basically for the health monitoring, directly from the data captured from the IoT devices would be monitored directly in real time, and the next necessary alerts or the necessary actions would be taken in case of anomalies. And by the way, analytics happens over the collected data, where the data collection will be already there. Mostly the data will be in the cleaned format. It would have gone through some ETL perspective, and it will be answering the business questions. For example, here you could see the downtime versus loss of production. Whenever there is more downtime, uh, how much loss of production has happened. So this also you could see that the green indicates that loss of production in volume. In the consider that the amount of volume that has been sucked out from the ground, and the downtime hours it has incurred in total in the March month. So you could see that even though the downtime is reasonably, if it's 400 hours in October, uh, it has also incurred with the huge loss of production as well. So October is the one which has hit hard. But whereas in the May month, even though the downtime was around 440 hours, the loss of production is not pretty much. It is just 100,000 barrels. So May month has did well, even though there was more downtime. October month has not did well, even though the downtime is not so high. So that's how the business questions will be answered uh, over the data captured from the IoT devices. And sometimes both the monitoring and analytics would be happened or made visualized in the same dashboard itself. I just picked up this example, which this is nothing but turbine wind powers example, where you could see that it is showing the total power generated as of now, and predicted power generated over next 6 hours, and uh, when was the last maintenance has happened, and it itself telling that when the next maintenance should be done. It is predicting with the historical data. So these are all the analysis data, and you could see that the live data as well. What is the wind speed, what is the temperature, what is the humidity, what is the wind direction, what is the rotation per minute, and even the angle. So all these are very real-time data, and that changes even by minutes. So this is also being captured. The business data has also been captured, and you can also filter out this data by selecting the specific wind farm, or by selecting specific turbine windmill as well. So these are a few examples. Now let me talk about 4 different analytics that happens over IoT, in the IoT world, right? So this is a very common slide you could have seen in many places. Uh, the analytics is of 4 types, where you will be getting higher value, but you will be having more difficulty to achieve. So that's where descriptive comes with the reasonable value, but with you could get it with ease. Whereas prescriptive analytics, you could get higher value, but it is far more difficult to get the proper insight. So that's where this chart is showing. Now let me just explain this in terms of a simple example. So descriptive analytics is nothing but you will be finding answers for what's happening or what has happened the past, right? So you will be checking out that monitor if things are going as planned. For example, as I told earlier in this thing, as a team, you would be given a goal that even though your downtime limit could be so and so, but the loss of production should not be so and so limit. So this is a planned one, right? That could be analyzed whether the production has not gone down too much due to the downtime, right? And of course, if there is any anomaly in data rise, the alert in the sense the respective business people will take respective alert decisions, right? So a simple example would be how much energy is this machine using right now or yesterday, right? When it comes to diagnostic analytics, it is nothing but why is something happening? Domain experts do this diagnosis on data by drilling into data, and they'll be improvising the process by identifying the core problem, right? So simply the question would be, why is this machine consuming excessive energy? This could be the question, and they'll be drilling down with a lot of data, with some external data also, and they'll be finding some insights, and they'll be act accordingly. Predictive analytics is nothing but predicting about the future. So descriptive and diagnostic is about the based on the past data and finding insights on that. And predictive analytics is nothing but you will be predicting something which is going to happen in future, right? So what will happen? That would be the question. And the end user app will be using pre-prepared machine learning models with the current input to predict the undesired outcome, right? So as you saw in this turbine example, it is predicting by itself that the next maintenance is going to be 22 days. And the prescriptive analytics is nothing but what action should I take? So when we go to doctor, doctor will be writing us a prescription, right? So in simple, he's telling that, okay, this is what happened, and this is your prescription. Prescription is nothing but the list of medicines or the list of guidelines you should be doing in a couple of in the upcoming days to overcome the disease you would have got, right? So similarly, prescriptive analytics is nothing but the model itself, the app itself would be providing you some recommendations for the prediction it did, right? So mostly it will be taken care, it will be implemented in very critical areas. One example would be the same rig example, which I have told earlier, which will be used in the oil fields. While there is a very high temperature, it detects a very high temperature, it will shut down the machine automatically. Similarly, in very sensitive areas like nuclear plants and all those things, it will be sensing the temperature or whatever the data in very short time, and it will not wait for the other people to take action, right? So whenever there is a critical thing that is happening, whether it is power shutdown or something like that, automatically that nuclear plant will decide what should be done. Either it has to shut down all the operations, or it has to enable the cooler, or whatever it may be, right? So so these are the type of analytics. And once again, I have produced a simple example considering one single domain, that is energy and the turbine power. These are the very simple examples to understand in a layman's term. So who would be doing these things? Who builds this IoT analytics? Majorly, there will be two persons involved in the engineering team. I mean, in the team, one would be the data engineer, and one would be the data analyst or the data scientist. These are the people who hold these roles, as the core users and who powers up the IoT analytics as well. So data engineer holds a major important role, demanding job position as well, but not getting prepared before he joins in the company. What he does is uh, mostly he takes the responsibility of collecting the data from devices, and make sure that it is properly prepared and the respective ETL is done and it is properly stored for the analysis. That is the role of data engineer. It is not confined to IoT analytics. It is common for any analytics pattern, but I'm just talking in terms of IoT analytics. When it comes to IoT, obviously he should be more familiar in the data collection area, right? He should be familiar with technologies like Azure, even Hub or Kafka and all those things to take care of the data collection as well. Because if you lose the data, then it is also going to render into the data quality issue, right? We'll be checking out that in detail while we see the demo. And obviously, the data scientists, I mean, the data analysts or data scientists, mostly the descriptive and analysis will be done by the data analyst, and predictive and prescriptive analysis, that is creating that particular machine learning model, will be done by the data scientists, right? So these are the people who produce and communicates the operational insights by exploring and visualizing the data. So now let's see how analytics can be done. So as you all know, we do have on-premise environment, cloud environment, and hybrid environment. Usually, uh, if it is going to be on-premise, that is, if the data collection is going to be very smaller kind of thing, maybe in an industry, a couple of machines will be there, and there will be one engineer who would be taking care of all the operations, right? Full stack data developer, we can say like that. So in that case, the collected data will be stored in a CSV file, and once the data is collected, he might be using some ETL tool like Talent to do the ETL purpose, to do the transformations and the cleaning purpose. And he might be using a system like Apache Spark. Even a single node Apache Spark cluster would be more than enough to do the basic analysis. And once the complete analysis, I mean, once the clean data is available, he might even check out the data by connecting with Power BI, or he might even use the clean data to train some machine learning models as well. So this would be the very common scenario when it is been happening in the on-premise. Whereas when it comes to cloud, to get the business value from those huge data, combination of tools would be needed. For example, you might be needing a data lake. This scenario would be the cloud adoption would be there when it is going to be a huge infrastructure, right? Just consider that there are many thousands of IoT devices are there, or even hundreds of devices are there, and and the purpose is to get the business value from the captured data, right? So in that case, this would be the architecture pattern for the IoT analytics in perspective, right? So as I told earlier, combinations of tools would be needed. It would start from the data lake to store the data, and stream processing frameworks, and even analytics tools like Databricks, right? Apart from these services, Microsoft Azure Stream Analytics can also be integrated with Azure IoT Hub and Azure IoT Suite to perform real-time analytics on the IoT sensor data, right? So for today, for this session, I'm going to use this architecture pattern, and you will be seeing that how the data ingestion is being, I mean, not this particular portion. I'm not going to configure a Kafka cluster or something to capture or ingest the data. The process would be starting from here, how the raw data would be there, and from that, how that raw data would be injected into Parquet format, and then converted into Delta format, and then even converted into again reconverted into Delta format with aggregated results, and how the insights are being captured. So within that, there are common things would be happening. The schema would change for the new data, or some complaints would be there, like GDPR complaints, where the username information should be deleted, and it should the captured data should be kept as anomaly user. Sorry, anomaly user not. Should be kept as unknown user, and all those real-time scenarios would be there, and I'll be talking about those things as well. So let me jump on to the next thing. So I just listed out the different technologies or the Azure services which are available when you are designing the data infrastructure for the IoT. And perhaps you would be thinking that why cloud is being important, or why cloud is being given importance for IoT analytics more, because it is conservative in investments. What I mean here is you would you would kickstart with a very small provisioned environment. Just check whether you're able to get insights or not. Just check whether you're able to get the business value out of it. Once you confirm, you can scale the environment. That's what this example also mean. A baby would be first crawling before it is walking. Similarly, it will be just walking before it would run, right? So that's why we can scale in a very slow fashion based on the return on investment we get. And obviously, you could scale compute and storage independently when you use systems like Azure Databricks. And I'll be telling that during the demo as well. And this is a very simple slide that just to explain in specific industry and the specific corporation which IoT platform it is being using. This is a very general slide if you want to deep dive how each corporation is using this IoT platform and how they are capturing the return on investment out of the data. So obviously, hybrid environment also there would be there. I'm not telling that strict on-premise or strict cloud. A hybrid environment would also be there. So now let me jump on to the demo portion. So I have already provisioned Azure Databricks cluster, and before that, let me jump on to the StreamYard and let me check if you have any questions. Okay, I think there is no questions, so let me just proceed with the demo. So you could see that this is Azure portal, and I have created a new uh, a Databricks environment. For a quick purpose, let me just click how let me just show you how I have created an Azure Databricks environment. So Databricks is nothing but uh, Spark environment that has been provisioned in cloud, right? So Azure Databricks is nothing but that Spark environment will be provisioned in Azure environment. That's it. So you would be having some simplicity if you are having all other ecosystem around Azure, right? That could be your data storage could be in Azure Data Lake, and your team would be using Power BI for visualization. In all the scenarios, you could pick up Azure Databricks, right? So as usual, when you come into the Azure Databricks, you can create a new cluster, and it will be asking you for some information in which resource group it should be stored, and what kind of the subscription name, and which pricing tier you would be needing, whether it is standard or premium. So this particular thing is specifically different from the actual Databricks, right? Azure Databricks and Databricks differs in this particular perspective, because uh, once you create a cluster, it will by default it will give you the user management purpose with Azure AD, right? So if you are in a company, let's consider that I'm in a Kistro company, and the Databricks cluster will automatically deploy with the Azure AD that I am having in my Kistro company. So obviously, I'll be able to share my insights to my manager or to the CEO or whoever. I can assign some specific task to my engineer. So all that happens easily via Azure AD, right? And of course, premium comes with the role-based access control, where you could even give fine-grained access control permissions over the tables you create uh, based on different roles, right? So once you have this option, and you can just overview and just create it. So for the time purpose, I already have a cluster created, and I have just opened it right here. So for this demo purpose, what we are going to do is we'll be provisioning a part a CSV table, and we'll be converting it into pathway table and then into delta table. The data is nothing but the health tracker data uh, that has been emitted out of just consider a health tracker device. A patient would be fitting, right? The heart rate and all those information, right? So once the delta table is available in this demo session, we'll be analyzing it and making it ready, and making it single source of truth for the further analysis. So let me kickstart one by one. So I do have a Spark cluster, and so this is going to be the first step where I have some data that I have already stored. So as you could see there, these set of months, I'm going to retrieve those data, and this is the JSON file that is actually going to have the data. You could see that this is the path, and this is the file name, and this is the size of the file, right? So this is a very simple first step of collection. I'm just confirming that my raw data is ready, or my raw data is available in the data lake. So the next step, I'm going to do the first initial review of that raw data. Okay, so this is something in the industry they'll be calling as data profiling. Before you start to analyze, or before you start doing ETL, uh, the initial data profiling will be done. So this is that portion of thing. So as you could see, we just mention the respective file path, and we just create a simple data frame by reading that particular file path, and it is simply telling that this is the respective schema. We have four columns. One is device ID, heart rate, name, and time. So you can understand that this particular health tracker IoT device is capturing the heart rate and storing the data into a data lake. And in this particular demo, we are going to analyze that heart rate data of the patient, and how the device is also performing in terms of capturing the data, whether the device is performing well or not, right? So once I'm just visualizing this because it is very simple, four column data. There is nothing much. You can even visualize it is in a table format, or you can visualize it in a in some visualization format. So as you could see, uh, once visualizing it, I could see some anomalies. The y-axis is nothing but the heart rate, and it is simply showing that the device one is producing some negative heart rate, right? So this is obviously not possible at all. A heart rate will not be negative. Okay, can you please enable full screen? Keshavan has asked. It is already in the full screen. What do you mean by that? I couldn't get. Okay, maybe I could increase the browser size so that the text could be visible. So if you face any further difficulty, Keshavan, please let me know. Right. So as you could see, there are anomalies in this particular captured data. Device one has captured four times, has captured and stored as negative values of heart rate four times, and of course device 4 has captured negative values for two times for the captured data as of now, right? So we are pretty clear that even though we have more data, more correct data, there are some incorrect data as well, right? So we have just kick-started with this portion, and what we are going to do next is we are going to create a parquet table out of this captured data from the data lake. So you could see that I have specified the file path, and I have created a data frame over the file path as well. And what I'm going to do is I'm going to, for the safer side, if the table is already exist, I'm just deleting it, but we can just ignore this. So we are just going to do the transformations before that. So as you could see, we just have one particular column, that is time, but that is captured in a universally common format, that is Unix time format, so that a person from India also can analyze, or a person from US also can analyze based on his need. He could convert it into different date format or a different time format as he need. In this case, I'm just splitting out the 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 actual Unix time into the date and timestamp. So I'm going to create two new columns out of the original column. Okay. So, and also I'm going to typecast it the device ID as integer. By default, the device ID is in a long data type, but we particularly know that the device ID is going to be 1, 2, 3, and 4. So simply I'm typecasting it to integer, right? So these are the simple transformations that I have did. And as you could see, I'm creating I'm writing the files to a process directory that should be in a parquet format, right? So once I have did this, let me check. Let me create the table first of all. So health stacker processed using parquet. I have specified the format as parquet, and I have specified my location as well. In that case, the table is being created successfully. But now what we can do is let's check the number of rows present over this parquet table. As you could see, when I execute this step, I'm getting the output as 0, right? Because we have created a Spark table, Parquet table in Spark with the location specified. That's it. But we haven't what to say. We haven't the meta store is not updated. Okay. So what I mean here is, if you create a table, let me just show you what that particular example. So I'm just navigating to the data section. In this case, if I create a table directly in the Apache Spark and insert the data into that Apache Spark table by uploading a CSV or something, the metastore will be updating by itself automatically. But in this case, I have my data in the data lake, and I'm just creating a virtual table in Spark. But my actual data resides in the data lake, right? For the single source of truth purpose, I'm having my data in the data lake. I'm just creating a table in the Spark. In this case, we have to update the metastore, right? In Spark and Hive language, we need to register the partitions, right? So to do that, we need to simply execute this command, msck repair table health stacker processed. So this repair command, what it will do is, it will check whether the partitions are updated in the Hive metastore. If not, it will do the registration in the Hive metastore, and the respective partitions will be updated in the Hive metastore as well, right? So what next is, uh, now let's check the count, and obviously we are getting that, right? Because we have updated the metastore, and we have the Spark table as well. So what next we can do is, let's create the data table. So at this point, we do have the Parquet table. Now let us create the delta table on top of the Parquet table, right? So as you could see, before that, let's just explain. Using the describe command, let's just describe health stacker process table. So it is simply showing that all the metadata information, and as you could see that the provider is updated as Parquet, right? But for what we need is we need the table in delta table format. In that case, now let us for doing that, the first step should be the actual files, the parquet files need to be converted to delta files, right? So in this case, I'm mentioning where is my parquet table, and I'm specifying the partition scheme as well. That is on top of which column the partitioning scheme should be happening, and I'm simply using delta table dot convert to delta table, and I'm mentioning my Spark session, the parquet table, and the partition scheme. Once it is done, the conversion gets happen, and we have the converted delta files converted as well. Next, as earlier we did, we need to register the delta table. So now let's use the same thing, health tracker process, and now what we are using is using delta. In the previous notebook, we have had this as using parquet, right? Now we need to mention it as using delta, right? Once this is done, the delta table gets updated, and even we'll be able to add additional columns in the delta table. In this case, I'm just adding a comment column where for the ease of purpose, some information will be updated in this comment column. So that's a very simple thing. So now let me explain the same uh, delta table name. Now you could see that along with all the metadata information, the provider has been updated as delta. Previously it was pathway. Now it has been updated as delta, right? So now let's do the count over this data frame where it has been where the delta table is being read. While we are reading it, we are able to see that the count is 37220, and also you could see that we did not updated the metastore, right? Because since we have created the delta table on top of a parquet table, and the metastore information is also available, that update is present automatically, right? So uh, and yeah, and as I was telling in the uh, architecture diagram, so you could see that we do have the data ingested in a data lake, and we have brought the data into Azure Databricks. That is the raw format. And what we are going to do is next, we are going to convert it as another delta. I mean, once again, we'll be converting into another delta format, from delta format into another delta format. For the understanding purpose, here it has been mentioned as bronze delta table and gold delta table. Bronze delta table is nothing but the raw data, raw cleaned data, and gold delta table is nothing but the aggregated data, which can be used directly in any analytics reporting tools like Azure Synapse Analytics or Power BI to do the analysis, right? This one silver uh, converted data is just to just understand that it has also incurred some transformations, but that will be primarily for the to train the machine learning model, right? So this purpose is to train the machine learning model. This purpose is to directly analyze the delta table. So coming back, um, so we are going to create another delta table where we are doing some aggregation operations based on some columns. Like here, you could see that health tracker gold user analytics table is being created on top of health tracker processed, grouped by device ID, and it is being done with the aggregations over heart rate, right? Because this health monitor device is capturing heart rate as the primary data. So once it is done, we are writing that data into the health tracker gold user analytics table, and we are registering the new delta table in the metastore. Okay, and as you could see that once once I visualize this data within this notebook itself, I can do basic analysis. Or if I'm connecting with Azure data, if I were connecting with the Power BI also, I'll be able to analyze. So you could see that it already has the aggregation information, and you could see the different thing. So maximum health rate and the average health rate and the standard deviation health rate between different devices, right? So with that, we have created that actual delta table. And what happens next? We have created delta table with historical data. I mean, sorry, not historical data, so far captured data. And obviously, the device will be producing new data also, right? So the new data has to be made, loaded into the delta table whenever it is been coming, or once in a day or twice in a day, based on the business use case. So this is the new data. As you could see that the _2 for the demo purpose, and I'm converting it as a data frame, and I'm checking the schema of that. So everything is fine. So obviously I'm converting that into processed data frame, because I was doing some processing, right? The time is being converted into date and time value. So I have created a Python function and directly passing my Spark session and the data frame. So it results me with a processed data frame. Now my Unix time is being converted into date and time, and my column is also changed. Device ID column is also changed. As you can see, the device ID is being converted into p_device_id in integer data type. And obviously, I am going to append the data into the processed data table. So the data would have been updated. Now let us see that. Now let us see a different concept called versioning, right? So one feature what Delta Lake has is you would be able to time travel, right? So you can configure this version as well. Now, with this particular step, you have updated the new data. Okay, just consider that there is some issue and you need to reverse it, right? You need not update the new data, and you need to remove the new data insertion, revert the new data insertion. A simple example would be the control Z. If we type something wrong in while typing in the Microsoft Word, if we do the control Z, it will automatically gets back to the previous version, right? So like that, you would be you would be able to go back to the previous version of the data. Okay, so with this step, the new data has been inserted. Okay, but you think that you need to go back to the yesterday's data, that is version 0 of data. You could simply use this version as of function, and you could specify the number. So you are mentioning that go back to the version 0 of this particular table, right? So you could see that the table is producing the output as 3720. That is the actual count of records which was present while we were executing in the till the previous notebook. Okay, now let us see how much we have the actual data till now, right? So when you execute this thing, spark.read format in the format of delta, the actual table, it is producing telling that 7128, right? So the delta table health tracker processed has is having the version as version 1 as of now. Okay, so that's about the version control. Now let's check out another common use case. So okay, for the time purpose, this is about single source of truth, but it is not so important. So let's jump into the next thing, upserting into a delta table. So upsert is a command which is nothing but doing two operations. It will do both the insert and update, right? So that's why it is termed as upsert. UP from the update, SCRT from the insert. So it will be doing both the operations, right? So while analyzing, while during the data profiling, we just saw that some records have broken readings, right? The negative heart rates were there, right? So in this lesson, we are going to fix the broken readings, and also we are going to update missing records as well. So basically, the data cleaning operation happens here. So what we're going to do is we will be preparing a data frame which will be containing the uh, which will be containing a common average heart rate based on the previous and next value. Okay, there are out of those 7,000 records, just 60 heart rates alone is missing. So as a data analyst, I am deciding that average of previous value with the next value can be calculated, and let's update to that particular heart rate. Okay, instead of negative value, let's update that average value, right? So even though we are not getting the original heart rate at that point, instead of having a negative value, we are just computing an average value. So I have this data frame, and I just check the schema whether it is right or not. So I'm converting into that, and once I do that, I'm checking that, okay, what happens with this, the actual table and and my new data frame, whether both the data frames are having the same schema. It is having the same schema, and I'm also checking that how many number of records are something like that. So as we know earlier, the broken records are 60. My update data frame is also 60, so I'm going to update 60 rows in this case. So now uh, what happens is we also have that problem of missing records, right? So just consider that those missing records are nothing but the data has arrived late, so that has been captured in another JSON file. So we do have the data, but in this case the schema is not right, so that has to be converted into the schema of delta table. So we are doing the transformation, and we are reusing the same Python function, process health tracker data. I'm passing the Spark session and my missing data, right? Missing data, I'm passing that. So in the inserts data frame, that missing data gets updated. So I'm checking the schema, it is fine. And so we have two data frames right now, right? So we have updates data frame and inserts data frame, and both are of same schema. So using the union function, I'm creating another data frame to combine this updates data frame and inserts data frame. So this upserts data frame is the one should be updated into the actual table to convert the original data into far cleaned data. Okay, so I'm checking the schema, and with the simple operation, I'm just merging the upserts table into the processed delta table. Okay, so now as you could see there, we have did another we have created another version of table. Version 0 is nothing but the actual original data that is being converted as delta table. Version 1 is nothing but we have added 1 day of new data into the delta table, and version 2 is nothing but we have did the corrections, that is broken readings and the missing records. We have did that corrections, and we are updating it as version 2, right? I mean, it has got updated as version 2. So I'm mentioning the version as version 2, and now I could see that the number of tables is 7128. So there the previous one was having around 7,000. Now along with the updated 7128. Now along with the updated data, we are having 7,200 as the updated rows. Okay, so even we will be able to see the history, what are all the version it has passed on. So 0, that is the original version, and 1 where we have added the common column, 2 where we have inserted new data, 3 where we have performed merge operation to upsert the broken records and new missing data. Fine. So with that, let's jump on to the next thing. So another scenario is we might be having a situation that the new data is coming with the new schema, right? So in that case, the Delta Lake will not be accepting by default, because it will do the schema check very strictly. So let us see how to handle that scenario. So in this case, the new data, we are having another new column called device underscore type, right? So this is a new column that has arrived. So while while I do the initial transformation and insert the data, you could see that an exception is being raised. It is telling the schema mismatch exception. But as a data analyst, I'm fine with the, I know the schema change, and I'm fine with the fact that previous data will not be having this new column. Only the upcoming data will be having this new column. I'm fine with that. So in that case, I'll be telling that, okay, you enforce this new schema, do not throw error, right? So in this case, I'll be mentioning another parameter here, that is merge schema, and I'll be telling the value as true. In this case, it will accept it, and you could see that the new data has got updated with 10,920 rows. So yeah, and another typical scenario is you might be needing to update some old data based on some complaints. So in this case, let's consider that under GDPR, the regulation has passed that you should not be storing a particular user information into your historical data, right? So in that case, we don't need to delete all the records, but just update that information, the username information as null. That would be more than enough. So in that case, I'm updating that particular name, this name information alone as none. Okay, that too for the device ID. I can even specify that device ID. Consider that out of 5 devices, this device number 4 alone is being used in Europe. That requires this GDPR correction, and other devices are being used somewhere in Africa or some other country where there is no strict GDPR exist, right? Just consider for an example. So for this device ID, I'm recorrecting that the name column should not have any value, and it should be updated with null. Okay. So in that case, I do the respective scripting, and I update with my original table as well. And as you could see here, uh, where is that? So let's check the most recent version of data, and you could see that for device ID 4, all the name has been updated as null, right? But there is a catch over here. The delta table has a feature to revise it to previous version, right? So this is the latest version, and as a programmer, if I revise it with the previous version, that is version 4 or version 3, the data would be having the name value, whatever it is, Peter or name or something, right? So in that case, yeah, this example shows that as of version 2, I'm still having the name. That is the delta table as part of Azure Databricks. The delta table still stores the previous version of data, right? So in this case, I can vacuum the previous version of old files and tell that you do not capture the previous versions of data, and you can just flush it out. It helps in two purposes. One, to comply with the complaints and the new ads, and the other thing is to save the delta table storage purpose, right? You do not have too much of old versions of data. So if you run this particular property, and if you execute to vacuum to delete the old version of tables, to delete the old versions, and then obviously the old versions will be deleted. And again, once this is executed, if you attempt to query an earlier version, you are obviously getting this exception, file read exception, file not found, because ultimately your tables are nothing but stored as delta files in a delta lake, right? So that's why it is producing a file read exception. So that's with the demo of this particular architecture. We have the original data in the data lake, and we have just moved it into Azure Databricks with the partially clean data. And we did some cleaning by addressing the broken records and negative values, and we created a gold table where it is having aggregated information with clean data as well. And we just consumed, we just did quick analysis in the notebook itself to what to say, to capture some insights, right? So coming back to my slide, what are the actual real-time challenges in the industry? So actually there will be too much data, but the company would be most of the time company would be hesitant when there is too much data, right? Because to process that much data, a spend is required, right? The cost for Azure Databricks, the cost for the engineer to pay, and all those things. But he would be considering that there is a chance of lesser business value upon playing with too much data. So it is always a challenge to capture only the needed data. And another challenge is heterogeneous data. Uh, Even though the sensor is same, for example, the heart rate data is same. The heart rate is the actual data. Different companies or different devices within the same company manufactured in different time will be producing data with different schemas. Even in our use case, we face that, right? One data was being produced with a new column, that is device name, right? So such a kind of heterogeneous data with complex changes are always challenging for the data engineer to club it up with the previous data. And there is general security breaches exist. And if that IoT device is not so secure, and if there is any security breach, the trafficker or the attacker could save incorrect data, or that would in fact produce raising false alarm, or that would produce in fact result in producing incorrect insights, and all those problems are there. And obviously the devices problem, there could be some hardware failure due to low battery or power shutdown. The data might not be collected, or due to some software bugs, maybe in that uh, IoT device, the Raspberry Pi or something might have some bugs and might be producing some incorrect data. And all these things are major challenges in IoT analytics. So this is a quick slide. It is not that training alone is enough. It is not that big data alone is enough. That we definitely need correct data, right? This is a meme I just saw, so I'm just mentioning over here. And there is also a chance of adversarial attack if the data is being corrupted with some wrong information. The model might fail to recognize that, and it will be getting trained with that incorrect data. So apart from this data gathering and preparation and analyzing, there are other factors as well, as you could see here. For the data catalog, is nothing but making the data set discoverable to everybody. That is from the data analyst to data scientist. That comes under the umbrella of data catalog. And data governance is there. The Based on the company's complaints and the acts, the IoT analytics infrastructure has to be produced. And first of all, the problem has to be understood very clearly based on the domain, and the person who does should be thinking as a user, and obviously sharing the insights. It's not that sharing the insights via email or something. You might even need to share that insights as a dashboards, or as Python notebooks itself. So that effective collaboration skills and sharing insights is needed, right? So with that, I end my talk, And if you have any questions, please let me know. I would wait for 30 seconds, and if there is any questions, please let me know in the YouTube chat. Okay. So I don't have any questions. Thank you, Keshavan, Babu, and others who are listening for this talk. And I'm ending this session. Thank you. Bye bye.